GemStone knows about adjustments.
And it's been around for a long time.
Very persistent.
Very persistent. Okay. Dale Henrichs, I'm a principal engineer at GemStone.
Microphone.
Pardon?
Microphone.
Oh, microphone. Yes. I had it on here somewhere. Is this good? Okay. So, yeah, my name is Dale Henrichs. I'm a principal engineer at GemStone, and I'm going to talk about Voyage-Tugrik, a new persistence option for Pharo on GemStone S. So I'm going to get the initial question out of the way. What's Tugrik? What is that? Okay, where did you get that? So I'll start by just a little bit of background. So about the beginning of this year, I had kind of gotten Toad to a good stable point. And GS Dev Kit, Toad is a development environment for GemStone S open source. And I have a set of scripts for managing stones and to make it easy for people who don't understand GemStone to run, create stone, start stone, stop stone, etc. called GS Dev Kit Home. That has stabilized it as well. So by the end of the year, I was kind of in a position where I could go and say, well, let's now get something that will use Toad and GS Dev Kit Home. And I was looking at, I was thinking maybe Voyage would be a good vehicle for introducing GemStone to the Pharo community and make it a little bit easier for folks to use GemStone. The previous model has been developed in Pharo deploying GemStone, but you have to make up your mind ahead of time. And there are slight differences between the way you would do applications. And especially if you went down the Voyage route, an application written with a Voyage-style, active record style is not going to move easily to running in GemStone without changing your application, basically. So something based on Voyage would be a good idea. So after playing around with Voyage just a little bit, I realized that maybe the best route to getting a persistence layer, simple persistence layer in, would be to take the MongoTalk implementation, which is used by Voyage Mongo to talk to a Mongo database, and emulate it for GemStone. So that basically the same Smalltalk API that you use to talk to MongoTalk could be used to run against a GemStone database. And so that was back, I guess December, January this year. I kind of thought that's a good idea, and so that guy ultimately became and turned into Tugrik, because the Tugrik is the Mongolian dollar, and a Mongo is the Mongolian penny. So that would be a very, that would make 1 Tugrik is equal to 100 Mongo. So, pardon? Oh, you've got to take pictures, yes. Oh.
That's okay, we can delay for this.
All right, so most of you know what Voyage is. Who knows what Voyage is? Who doesn't know what Voyage is? Let's see. Okay, all right. So Voyage is a persistence layer for Pharo, and it's basically designed to run as an object-to-document mapper, all right, for NoSQL databases. So a lot of the NoSQL databases, MongoDB, a number of them just have a document-style API where you're just storing dead objects in the database. And Voyage was done, I think, first for Mongo, and now there's variants. I think somebody did it for React, and there's now Untitled, which Esteban will be talking about later. And basically, it's a very, very simple API, all right? And when I say an active record style, does that ring a bell with anyone? I think the idea is that you create objects in your client and then you save them to the database. And there are rules for what gets copied and where you have boundaries for root objects, all right? And so that's a key concept in Voyage is root objects are actually managed as first-class objects. Other things that aren't roots are copied and not necessarily shared, all right? So you create a document for each root object, basically, and you have collections with collections of root objects in different classes. But there's 6 methods that are used for this. Save, remove, and then a couple queries. And the other important piece, I think, is that there is no Voyage query language, so there's no attempt to have a unified query language across all document databases in the universe, all right? And that's on purpose, because each document database has unique capabilities and characteristics that you wouldn't want to have to mess with. But it does turn out that right now, MQ Query was created. I'm not sure, did Nicholas do that? Nicholas Baton?
Yes.
Okay. Did MQ Query where he could take a Smalltalk block and convert it into a Mongo-style query. All right. And I'll talk about that, I think, a little bit later in my emulation about what that means. But it does mean that there is a kind of a de facto standard of a small subset of blocks, stylized blocks, that can be used as queries in Untitled, Tugrik, and Mongo. So hopefully that cleared up a few things. Let's see, so GemStone S, yeah, I think if you saw James's presentation, then you got a whole lot more information, but the basic idea, GemStone S is a multi-terabyte Smalltalk image. There are thousands of concurrent Smalltalk VMs making updates to a shared image. There's thousands of ACID transactions per second, all concurrent image saves. And there's a generous, free for commercial use. So we can do terabytes and we can do 10 megabytes, which is, or 10 gigabytes. The free license that Norm mentioned this morning that comes with the download gives you a 10 gigabyte database and 10 sessions without having to do anything. If you, at the cost of an email, you can get a 50 gigabyte database with 20 gems, all right? And again, it's free for commercial use. There's more information at that URL. And I mentioned, well, I didn't mention GSDevKit Glass, but one of the things, if you were at James's presentation, you heard about symbol lists and symbol dictionaries and went, what? How do you write applications in GemStone? So the idea of GSDevKit Glass was to basically make a development environment, a class library that looks an awful lot like Pharo Squeak. So, for example, the Smalltalk global exists, all right? And it wraps the symbol dictionary and the symbol list for data curator, which is the user that we use, with a Smalltalk proxy and implements the Smalltalk API so that you can do Smalltalk add, put, etc., and your application continues to work. The other piece of this GSDevKit Glass is there's a large number of classes and methods that are present in a Pharo Squeak image that aren't present in the base GemStone, and so those have been added. And then GSDevKit Glass. So in 2007 we announced Glass, and that was GemStone, Linux, Apache, Smalltalk, and Seaside. And we had a virtual machine that ran that thing all in one piece. And so that was kind of what kicked this whole effort off. And so that was called Glass. Probably, I don't know, 4 or 5 years later, I split the Seaside out of Glass, and because there were other web APIs that didn't need to have Seaside in the image, and I didn't bother to change names and nomenclature and documentation, and etc. And so now I'm going to eventually be GSDevKit, but it's now GSDevKit Glass because there's too much confusion out there right now. If you start poking around, you'll see what I mean on the web. GSDevKit Home is a bunch of bash scripts for, about 30, for creating, starting, stopping GemStone database instances. And there's bash scripts for creating, starting, stopping Pharo clients. And I say Pharo clients, it's actually, I've written it to be against generic clients, but the Pharo clients are the ones that I've actually tested and used. So there's truth in advertising at this moment. It's supported on Ubuntu 12.04, 14.04 Mac OS, and not too long after the conference, 16.04. Okay, so what I started back in January was Tugrik and emulating the MongoTalk API. So Tugrik implements the MongoTalk Smalltalk API, and inside GemStone on the server side, I model a MongoDB collection organization. All right, and so that means you've got a named database, all right, consisting of multiple named collections. And root objects go into these multiple named collections, and your saves and etc. There's different rules at the Mongo level. You can control this stuff, and I'll have an example here shortly. Tugrik also supports MongoDB query filters. So in MongoDB, a query filter is a dictionary object, and they use those to filter things, and they have kind of rules. They don't have classes, so it's kind of like, okay, this dictionary, oh look, there's an and there. Okay, this is a query, and off you go to the races with that. But Tugrik supports that style of query filters. So, and it passes all the MongoTalk unit tests. So that means MongoTugrik should be able to plug into a MongoTalk application and run without problems. Should is, you know, a good question, but, you know, it's a proof of concept. This is an example of MongoTalk, Smalltalk code. You notice it, get my long finger. So at the top up here, in a MongoDB application, you would just say Mongo default, and then you run this code, which is MongoTalk code, to create a database named test, add the collection, test collection, and then to the test collection, add two objects whose key 1 is value 1 and key 2 is value 2. And then you do a select, and that's what a select where key 1 is equal to value 1 is how you interpret that. So that's what MongoTalk looks like in the client. On the server, when you do this dictionary at put, I create, and this is a Toad inspector, picture of a Toad inspector. So basically you have an instance of Tugrik object. This is the ID that is part of the magic of Mongo and Voyage, well, Mongo. And then here's key 1 and value 1. So this is what I'm storing on the GemStone side. And then this is a picture of some of the query filters that GemStone has implementations for and supports. Now there's others, and but I didn't go through the MongoDB documentation and implement every single form because I don't know whether that's needed or not. Is that, you know, so at this point in time I wasn't going to worry about it. So now Voyage-Tugrik is, this is why Tugrik was done, because Voyage-Tugrik meant all I had to do was subclass and specialize Voyage Mongo, and I'm off to the races with Voyage. And so really all you have to do is replace, this would be a VO Mongo repository and database blah, and then this code. And all you have to do is say, well, so let's use the Tugrik repository, and then all the Mongo code, or the Voyage code, should run just fine. And this is a case where what we're doing is creating a test pilot. The test pilot has been declared as a Voyage root, and then we're creating an instance of Voyage test dog, and it's a Voyage root. And then we're saying save, and when it saves, there's a Greek visitor that traverses the object that's being saved and creates copies object structure that are not roots and terminates at objects that are roots, although but roots that aren't saved. So this does a save of both pilot and pet because pet was not saved before. And then current select all, you're basically selecting all of the type test pilot, and that will give you all the pilots that you've added. So that's what that query does, or that Smalltalk code, Voyage code. And so when we did this, what ended up in GemStone is a Tugrik object, and an instance of VO test pilot, a version number. These two things are metadata for Voyage itself, and then these are the instance variables of the pilot. And we've got a creation date, keywords, a name, and a pet. So the pet reference looks like this, and this is a duplication of what is stored in Mongo by Voyage. And basically it's a reference to the pet instance, which is also in, you know, a Tugrik object, instance of, version, and a name. Now it turns out that it's not visible here, but the pilots go into a pilot collection, and the dogs go into a pet collection in this particular application. So, and the UID or the OID is used to look up the objects. So it's no fun to have a terabyte of documents that are not objects, not your objects, and don't have your behavior. So once I got the ability to store objects and had instance of, it became possible to store instances of your root objects in GemStone. And that's done by basically saying the DB server class name should be the class mapping DB server. So you're basically swapping out a class on the server, and it has different behavior. So again, you know, and then assuming that we've got packages loaded on the client and the server, with the definitions for pilot and test dog. When you go over to the server now, you end up having a VO test pilot instance on the server. He has a wrapper here that has the OID of the object, and this is a technicality right now, but it's good to show this because this kind of information is needed. And then here's the instance variables, and the pet is no longer a forwarder to the object, it is the object itself. So basically using class mapping, you can take your Voyage Mongo application with your, when you're working with Voyage Mongo, you must have an imagination of what your object structure looks like. Well, the full object structure will be built on the server if you use Voyage-Tugrik, and it will actually be what you think you're building. Let's see, I think that's all. So the second piece is, okay, I've got behavior. So now you've got dead named objects or dead classes on the server. Is that really what you want, and is that very useful? And so that's really the next challenge, was to how do you unlock server-side behavior, all right? Because now we start getting into potentially complex things of talking about proxies and, who's running where, and managing proxies, and do I want a proxy, do I want the real object? So this is Voyage. It's supposed to be simple, all right? So, it's interesting. I came up with a solution, this is actually about a year ago. I called it server blocks, where you basically define blocks that can be executed on the server, but you do that in your client code. So any place in your client code, you can wrap with a server block, and that executes on the server. But I saw a tweet just last week. Why send large amounts of data to a server program rather than sending a small program to the data? And in a client-server universe, you're talking about, should I suck all of my domain objects out of the database so that I can run a little program, or should I send a little program to my server where all the domain objects are living and alive? And that's basically what server blocks do. So the first example I'll show is I'm sending a small program to the server. I'm sending 3 + 4, and that executes on the server. And the way this works is you embed that expression in your client code, and the block source is extracted from the block, shipped to the server. The return value is serialized using the standard Voyage serialization unit, materialization logic, and you get it back on the client, so you get your 7 back. All right, well, that's interesting. So the next thing is using reflection, I can pick up the non-local temp variables, or non-local block variables from the context. So if you can say 3 + x, I serialize the value of x and send that across as a binding dictionary to the server. Your block is executed and returns the value. And now we get to even more interesting things where I actually write some Voyage code, and I run a block where I pass the pilot in as a reference from a temp variable. I've done a save, so my data is saved on the server. I send the message pet and return it. And at the end of the day, I picked up my client pet when I created it, and I picked up the server pet that was returned from here, and the client pet is equal to the server pet. Now, this is not GemStone magic, this is Voyage magic. Voyage has the IDs, the object IDs that you saw earlier are used to synchronize with the client as well, so you can maintain identity. If you have a copy of that object on your client, then the Voyage will guarantee identity. So let's see, what's the next thing? Okay, so great, you've given me the ability to run select blocks, select one from, and a limited dictionary-based, query language. What about executing, application-specific messages as part of your query? If you're executing blocks on the server and you have all the code on the server, there's no reason to have any, non-Smalltalk-style queries. Now, I'm actually using select one where, but you could just write arbitrary Smalltalk and send messages and return inside a Voyage, a server block on the server. And, as the extra added bonus, I figured, so, the implication of this, all right, is you have, in client-server applications, there's like a broad range of possibilities and ways to do things. And, but often you have to make those decisions. Where do the proxies go? Who's managing proxies? Or a GBS style where all objects are server objects and shared on the client and server. And you have to record changes to those client objects so that when you save them, they get written to the server. All these things have valid uses, but the server block just gives you quite a bit of power out of the block without a lot of cost. All right, because this is what one method is what implements the server block. But the interesting thing is I've implemented the whole Voyage API on both the server and the client. So there's no restriction, quote unquote, as to what code do you execute where. So you can execute a save on the server and it won't puke at you. The behavior of save on the server, well, that's an interesting question. What should we do? Should we do a commit? Because what GemStone does have is transactions. And in fact, I didn't know much about Mongo until I started trying to emulate Mongo and writing tests that I thought should pass and did pass in Voyage-Tugrik, but I was trying to figure out how come they weren't passing in Mongo. And part of the situation is Mongo guarantees atomic operations on documents. GemStone guarantees atomic operations on object graphs. Okay, so when you make 5, 6, 7, whatever updates to an object graph and then do a commit, those are all done atomically, and any conflicts are picked up and noticed by the system. If you do 5 separate saves of an object to Mongo, you have 5 separate commits, 5 separate opportunities for the object graph to get out of sync. All right. Now, to be fair, that's not necessarily, there are plenty of applications that don't care. But if you're doing something with Voyage where you're updating object structures and you do have the possibility of concurrent stuff, that's something that you want to think about. So, I think, there's a lot of potential here, but then there's also there's more questions, all right? I think talking to Norbert yesterday, if you were paying attention, I didn't use self in any of these blocks, all right? The current implementation of the server block goes, oh, self, oh, sorry, you can't run that on the server. But you should be able to. So this is kind of where this proof of concept is at. It is what it is. It does quite a bit as it is, and there are a number of questions, and those questions are things that I'm going to want to learn about from you guys. There are a couple tools. This one here is, if I run 3 foo on Voyage on server, this walkback will show up in your Pharo image, and that's your server stack, all right? And the proof is there's no GSN method in Pharo. So this debugger was built using the Toad debugger hooked into the GT, the Glamour mobile debugger, and so I used that framework and basically plugged in the Toad server into that. And so you can step, it's cut off over here, but you can step, save, etc. You might notice, I guess, there's not enough stack there for you to notice. The client stack isn't there, okay? It can be there, but, is it needed right now? No. When it's needed, something like we can add that. The other thing that I added was some of the Tugrik, their interactions from Toad. So on the server, the notion of Toad is that the whole development environment is a GemStone development environment, and the client is in Pharo. But Pharo has no business logic. It doesn't run anything. It's a dumb, very ultra-thin client that just does display. So all business logic is performed on the server. So these interactions I created in Toad so that I could have a confirm pop up on the client, have you click on the button, whatever, and come back, all right? And it turns out that this is convenient to have right now, so I went ahead and plugged it in. So you've got choice, confirm, inform, text, multi-line text, allowing you to essentially have a confirm run somewhere in your code that you just wrapped with, on server do and have it come back to you. So, what I need to do next, or what needs to be done next is, okay, I'm going to get nerdy on you here and say, okay, the session pool and cache refactoring needs to be done to match the GemStone model. Obviously, improve and add client-side tools. I showed you a debugger, and that's all that's there now, all right? But it's possible, it's easy to imagine that you would be writing code in the client on Pharo, and you'd accept a method, and that happened to be a shared method between the client and the server. There's no reason we couldn't just trigger an event and send that code down to the server and have it compiled. Make a change to a class, that gets sent to the server, we migrate all the objects for you automatically. And that's, that is kind of how I imagine this development environment would evolve to. Let's see now, hardened stuff. GemStone indexing. So indexing is there in GemStone. It's a feature of GemStone. I just haven't tried to hook it up to Tugrik and Voyage and figure that out. Because obviously, maybe it's not so obvious, but the Tugrik object that we saw earlier, let me flip back to that thing. Okay, so Tugrik object is a class, all right? And if you were thinking about this, you were going, it's got instance variable creation date keywords. What about pet? Well, he's got name. Well, I guess that's common. No, that's common, but how come all those instance variables don't show up over here? What's going on? So in GemStone, we have a thing called dynamic instance variables. This was done as a side effect of our maglev support for Ruby, and Ruby has dynamic instance variables, so we added that. And it turns out to be really convenient in this kind of application. So I can store instances of Tugrik object whose only instance variables are actually ID and OID, and everything else is a dynamic instance variable. So I've got behavior in Tugrik object that gives me the standard stuff, and I can just support any old doggone thing, storing it in any old doggone collection that you want. And in the, let's see, in this particular case, I mentioned the wrapper. The wrapper here, this is an instance of test pilot, and these are the instance variables, and wrapper is a dynamic instance variable. So this is dynamic, and basically this Voyage wrapper is the guy that maintains the ID. I could put the ID in the object, and it's like, the fact that I can do something like this means there's flexibility, and you can try a bunch of different things. And which brings us to, okay, I got a couple other, let's see, so indexing, transaction models, all right. In C-side, if you're familiar with GemStone C-side, you didn't have to write any transactions, all right? Transactions happened automatically at HTTP boundaries. When a request came in, you aborted. When the request was returned, you did a commit. And so, if there was a conflict, you retried, okay? That's not going to work in a Voyage application, using GemStone, because the point of using GemStone is for you to control your transaction boundaries, all right? If you don't care, if you don't have a need, then MongoDB document level transaction boundary atomicity works just fine. So we have to come up with some simple default operations, and I need help to figure that out. Replication and synchronization, all right? This is the big, the big ticket item when you're doing client server, all right? Using synchronization, how much of that object model that you suck over to the client can you just freely modify there, and how do you do that, and how do you manage it? And so there's questions there. I mentioned the automatic compile on server, and then optimizations, all right? And that one should be farther down on the list. So basically right now, I'm looking for partners, okay? As I mentioned before, the client-server space is just gigantic, okay? And, I've got a starting point, and depending on, what your needs are, you might be able to take advantage of this almost right out of the gate, all right? Or not, all right? And I'm not, I sit down and I go, my preferences, all right? I like to think of doing this as incremental development, all right, with actual users saying, this is the feature that I need, this is, you know, I kick the tires, I would use this, I would love it, accept, all right? You know, I would, because I want to add the features based on demand, I want it to stay simple, all right? It's too easy to get wrapped up in complexity, and the beauty of Voyage is there's 6 methods here, all right? And that you use. And, you know, I added on server do, all right? I don't know how far to go. I don't want to get more complicated than that, ideally, all right? So, staying simple is an important piece. And then thin clients over fat clients, all right? There are use cases for both. Right now, the path of least resistance for an application is if you're just doing document updates, and document atomicity is fine, but you have problems with concurrent updates, you probably could take advantage of Tugrik right now and get going, all right? Don't put it in production right away. Do some testing, and if you have the failures come in. If you have a large number of documents, all right, again, you know, you can, GemStone becomes you know, a natural and, you know, not a big step. And if you have a relatively thin client and a fat client and a fat server, want to try that out and play with that, again, that's, you know, there's not too much more work that would need to be done to make that happen. Mainly the transaction models need to be figured out. So if you're ultra thin, you know, I would say, yeah, let's go. Let's, you know, I would put your needs in front of everyone else, because that's the way I feel about this, is the folks that have simple needs will get met first and get off to the races and not have to wait for more complicated solutions. And, you know, I don't know where this is going to go. I really don't. I don't have a vision. I don't want to have a vision, you know, because I don't want to sit down and say, this is how it's done, and then say, sorry, it's not done this way. I want to stay as flexible as possible. And I think multiple approaches that can live together perfectly well. I put this, if you wanted to play with Voyage-Tugrik, these are the installation steps, and you basically clone the GS Dev Kit home, you set up the environment, you run install server client, and that, you know, installs some OS prerequisites, and also sets up some of the basic, you know, I guess the question was asked the other day of if you wanted to write scripts you know, just generic scripts, wouldn't you really rather write them in Smalltalk? And so I decided that I'm using Bash, but as soon as I start expanding beyond the capabilities of Bash, so like, you know, if I can't find the answer about Bash in 5 minutes looking on Google, I'm going to write it in Smalltalk. So one of the things that gets built here is I have a headless GS Dev Kit client image, Pharo image, that implements all of the stuff that was more complicated than I wanted to put into Bash. And that guy gets built at this point here for you. Then you create a client toad, and since I know how to build that, you don't have to tell me anything else. For creating stones, I've got these guys highlighted here, and I'm going to talk about, there's a Voyage stone, and it's off on GS Dev Kit home on the GitHub IO area, because I needed a place to say, you know, and be able to download things, and also have pull requests so that other people can add to this. This is my moral equivalent right now for GS Dev Kit home of the catalog in Pharo. All right, there's about 30 projects up there, and if you saw the Smalltalk CI talk, okay, this smalltalk-tugrik.stone is a configuration file for Smalltalk CI. And in Smalltalk CI, you have a Metacello specification that says, here's the baseline. The rule of thumb there is if the baseline, if the .smalltalk-tugrik stone is loaded from this Git repository, then that's where the baseline will be loaded from. And that's how Smalltalk CI works. And I'm just basically leveraging that capability to put the instructions for building a .smalltalk-tugrik for creating a client. So you can create a Voyage client that builds everything that you need with this line here, all right, GS Dev Kit. And this is the same code that's used in Smalltalk CI, by the way, for doing stuff. So you may have seen an example of Smalltalk-tugrik.stone. there's additional things that I've got in Voyage.Stone, which is actually, these are project entries in Toad terms. And a project entry is, what's the Metacello formula for loading? And if you've messed around with Metacello to a certain extent, you may be familiar with the locking concept, that you can lock a Metacello project, and what that means is that you lock a project against a particular Git repository, a file tree repository, and then if you load a configuration, like what I use this for is, I have my own local seaside checkout on Git on my laptop, or on my laptop and at work. If I load a project like Peer that goes in and wants to pull Seaside in as part of its requirements, dependencies, the lock will force the load to use my version, my Git repository, rather than pull it from GitHub. And that turns out to be, I think, a required kind of operation, that you have to say, for the repositories that I care about, I'm going to lock them all, and all images that use that are going to use the same common Git repository. So that's how, in this environment, I have a Stone and clients share the exact same Git repository. Now, on my project entry, I get that for free because that's part of the project entry. The other thing in the project entry is I have an install script, so I arrange to git clone the Voyage repository, the Tugrik repository, the MongoTalk repository as part of that. So again, the Stone and the client will share the exact same code on my Git checkout. So when I make a change from the Pharo client, that change can be loaded into the server. And so that's kind of, these are, I think, are important pieces to make this system work, because now when I sit down and I can start a Voyage client that I created here, I basically use the name of the Stone that I created, and the default, that client image started that way will automatically talk to that Stone. I can have other Stones. I can use the same client, start it up and point to the other Stones, and that client will run against other Stones, all right, by just changing this. And this obviously is, you can do this internal in the image as well. But why force you to start an image, run a workspace when you can pass it in on a command line? So I guess we've got a little bit of time, but any questions? Yes?
I have two questions. One is, you mentioned maglev.
Yes.
I haven't heard about
Yes.
maglev anything in a couple of years.
Yeah.
What is the status?
The status is that basically all of the maglev specific code has been open sourced, and so it's available up on GitHub. There is a small core of maglev devotees that are continuing to push maglev forward. Periodically, we make a update to the server in support of these guys. There's just, we're waiting for pull, in terms of our effort, we want to be pulled into the maglev, and we're not going to push the maglev. Because frankly, in maglev, the biggest issue for a Ruby user coming to maglev is they're not used to image-based development. And when you have persistent objects and behavior, you have to be aware of the fact, this is why, historically, Smalltalk hasn't used files. You can't go edit a file on disk, load that into your image, and have methods removed automatically, okay? So you have to think about what's the image, what's in the image, how do I manage the things in the image. And Ruby programs are not written that way, and Ruby programmers don't think that way. Now, the small collection of devotees, they see the value of image-based development and continue pushing it. So you said the second question?
Yeah, so a lot of what you showed looked to me like a small version of GemStone Smalltalk interface, which has been around for 30 years.
Yeah.
For VSC, VA, and VisualWorks.
Yeah.
So now you build up a second idea to communicate. Are you eventually merging, or are there any?
Well, okay.
What are the plans there?
Yeah. So the thing is when I talked about this broad range of client-server, a big field of capability that you can be dealing with, GBS is out on the far end. The GBS is GenBuilder for Smalltalk, and that's the product that runs on VisualWorks and Visual Basic. there's a fair amount of bookkeeping and work that goes into creating that interface and making it run in Pharo, okay? And so, we're at the current time, we're not planning on doing anything, all right, on doing a GBS for Pharo, okay? So A, and B, Voyage is not necessarily a competitor to GBS, all right? Just as I don't think of Voyage-Tugrik as a competitor to Voyage Mongo or Voyage-Untitled, all right? There are very good reasons to get started, and your first time you dip your toe into Voyage and Pharo is to use Untitled, okay? And to go ahead and use that, and if your application starts to grow beyond the bounds of what you can do in Untitled, well then maybe you look at Tugrik or Mongo and so on. And so there's going to be, so Voyage-Tugrik kind of fills the bill of, you know, okay, these NoSQL databases are pretty cool, but, okay? And when you get to a but, we might be able to take care of that without having to go all the way to GBS. And when I say all the way to GBS, for the folks that aren't aware, with GBS, you basically are modifying server objects on the client transparently, okay? You know, so I talked about exporting small programs to the server and execute small programs on the server. GBS is the ultimate in bring all of the objects to the client, execute code on the client, do a commit on the client, and have all your changes to database objects transparently shipped across the wire back again. Now, you know, it sounds probably worse than it is because, you know, the whole thing in this client-server universe is performance, right? You know, where do you want your execution to be? I saw a paper on, you know, fat client versus thin client from '98, and I've never seen it described this way. But the reason for having a fat client is you don't have to buy as much server resources. Everybody's got a desktop computer. Use it. It doesn't matter that you ship objects over to the desktop computer. Go ahead and, because if you have 100 users, you have to have 100 computers in your server farm, or you use 100 computers out on the client desktop. And you know, and that's a valid point, and it's a valid reason for using things like that. And GBS was a product written for a very fat client. But it is a lot of work to get it to do the bookkeeping necessary to make sure that when you make a change to this object that you send all this stuff across and that you pull how much, like if you've got a 100 gigabyte database, you just can't afford to have the entire object model sucked into your client to operate on. So, you know, there's trade-offs in this universe and there's no right answer. And so really that's why I see Voyage-Tugrik as a, you know, spanning the spectrum from what you can do with MongoDB up to, and I don't know where, you know, where the boundary is, because I don't know where the real problems, and if there's it'd be nice if there was no gap, but, anyway, so hopefully that answers. Yeah.
This block, which you related on server, could it reference temps from line method?
Yes, yeah, any of the non-local. Oh, okay, repeat the question. So the question is, in a server block, can it access arguments and temps from the client method? And the answer is yes, all right? Because it basically, whether the rationale is that we look for all non-local variable references, and non-local are external to the block. So that includes, now, you know, I would reference instance variables, but I couldn't find a way to do it. So instance variable references, I can find out that I've got them, but I can't find out the value. I tried to do that. But, you know, the rules are, well, it should work, you know, and so I want it to work, but instance variables I couldn't figure out. Self, I didn't have a solution for. I think I do now. But,
Non-local return?
Non-local return, I haven't done that, but I'm not going to sit down and go, you know, I'd have to think about it a little bit before I said, oh, that's impossible. So, you know, because, you know, we have, I think we have the ability to figure that out, you know, but I'd have to look at it. And that's the kind of thing, you know, I would also come back and say, you know, do you really need that, you know, and I'm going to not tell you no. But, and I would actually, you know, I want to say yes, obviously, but it was too hard. then I would say later, all right, my inclination. So, any other questions? Yeah.
What happens if you send object memory primitive or something like that to the server?
Yeah, so yeah, you've got some things that there's code that doesn't exist on the client or the server, okay? And that's true. And you get a message not understood?
Yeah, but a code that destroys your server, like that you
Oh.
get the image or whatever, or...
Okay, so basically the way to think of GemStone things, if I get it right, is that, so what happens if you kill your server? Is that's
No,
basically...
if you send a program to your server that can kill it, like
Yeah.
object memory quit, I don't know.
Oh, okay, oh, exit, yeah, system exit.
Something like that.
Okay, then it would exit.
Yeah.
Yeah. So the idea of server blocks is not to expose those to users of the system, to expose them to developers of the system. All right. So it's up to the developers to sit down and understand the scope of what's going on, and there's a for GemStone there is a GemStone. I can't remember now. Norbert, what's that package that? What's the package up on GemSource that has the stubs for all the GemStone classes? Okay, we have packages that have stubs for a lot of the GemStone classes, so that you can run code like RC. We have RC queues, reduce conflict.
Pharo compat.
Pharo compat, or it's the opposite. It's GemStone or something. Okay. Anyway, we have a class system. We could implement exit to say don't do that on the client, right? And that would be the standard answer. If there's things that you can't avoid, then patch, all right? And, try to avoid them, but you're absolutely right. There's, opening up that thing, but that's just as dangerous as giving them access to the Pharo image. So if you're giving them access to the Pharo image, they can kill the Pharo image, okay, they can kill the server too. What the heck? So, any other questions?
Before big power and big responsibility, that's starting.
Yeah.
Thank you very much, Dale.
Thank you.